Good day, everyone. Today I will be discussing the first topic of Quarter 2 module in science, the quantum mechanical model of the atom. The idea of the electrons to move about in an atom in specific energy level was suggested by Niels Bohr. Based on the model of the atom, electrons orbit around the nucleus just like the way planets move around the sun. The orbitals where the electrons move around represent the different levels of energy. For an electron, its total energy is changed as it moves from one energy level to another within an atom. When an atom absorbs energy, an electron is elevated to a higher energy level and the electron now is in excited state. When electron falls back to lower energy level, energy is given off again by an atom. Emission of energy could be in a form of light. Electrons moving around the nucleus do not have the same energy content. The higher the energy of the electron, the farther it will be from the nucleus. The orbitals where the electrons are grouped are called the shell or the main energy levels. The shells are designated as 1, 2, 3, 4, up to 7, or designated as K, L, M, N, or up to Q. However, the designated numbers are commonly used today. The tendency of the electrons is to occupy the lowest shell or energy level. Shells have subshells. Electrons can be found in four types of subshells: S, P, D, and F, with the maximum number of electrons in each main energy levels and sub-levels, which you can see in your screen. In the first energy level, we have sub-level S, which has a maximum number of 2. The 2 electrons will occupy the S sub-levels. However, in the second energy level, which has 2 sub-levels, S and P, the maximum number of electrons of the second energy level is 8. These 8 electrons are distributed in the S and P sub-levels. 2 electrons will go to the S sub-level and 6 electrons will go to the P sub-level. And so with the third energy level, S, P, and D sub-levels. The 18 maximum number of electrons in the main energy level will be divided into S, P, and D sub-levels. 2 electrons will go to the S sub-level, 6 electrons will go to the P sub-levels, and 10 electrons will go to the D sub-levels. In the distribution of electrons in every main energy level and sub-levels will follow these guidelines. Number 1, the Aufbau principle. Electrons will occupy the lowest available subshells. Next is the Hund's rule. Electrons must fill up all the orbitals in the same subshell before pairing up. Then, Pauli's exclusion principle. No more than 2 electrons can occupy the same orbital provided they have opposite speeds. Nitrogen, for example, has 7 electrons. The arrows represent the electrons it will be distributed in the lower energy level follows the Aufbau principle. Remember that electrons do not pair up in an orbital until each orbital in the sublevel has 1 electron. Unpaired electrons have a parallel spin according to Hund's rule. So in the P sublevel, in the second energy level, we have Px, Py, and Pz. If you can see, there is only one parallel spin or arrow up showing that electrons in that sub-levels. The arrangement of the electrons within an atom is called the electron configuration. Example, helium atom, which has 2 electrons. The maximum number of electrons in the main energy level and sub-level is 2. Main energy level. S is the sublevel, and the superscript 2 is the number of electrons. 1s2 is the electronic configuration of an helium atom. These show the mnemonic sequence that follows the distribution of electrons in the energy levels and sublevels. This sequence will be used in writing the electronic configuration of the atom. Superscript numbers will depend on the number of electrons in every atom. Another example is sodium, which has 11 electrons. Each electron is distributed in the main energy level and sublevel. So, the electronic configuration of the element sodium is 1s2, 2s2, 2p6, and 3s1. That's all. I hope you learned something. Stay safe, everyone.